How many people are new here tonight? Quite a few people. Okay, out of the new people, how many people know me? A couple people. Okay. So basically the spiel with all this, just so everybody knows. So I've been doing technology since the 90s. Started off in the Army, had my own business, a whole bunch of different things. Started doing YouTube videos back in 2009. And people keep going. There you go. Another person I remember, Ryan. So I started doing videos in 2009, and I was one of that first generation of YouTubers that didn't know we were going to be YouTubers. I was part of that generation where we didn't know what to call ourselves for like the first decade. Anyways, but what I found was fascinating was how many people I was able to help with technology education doing YouTube videos. And so the idea now is, what if we could take the lessons of the YouTube world and bring them into the physical world? And so the idea is free to the end user education. What if we just make hands-on technology education basically available to everybody? You come, you learn, you get empowered, and you go away. We abstract out the financial component from the actual education component. So if you come to silicondojo.com, so this is kind of our central landing page. This will show you the classes that are coming up. So tonight's class, the Raspberry Pi class. We're going to be having our first full day class for Python and programming with AI. That's going to be coming up in January. So this is actually going to teach you Python. So Python is our standard language here at Silicon Dojo. It's just a nice, good superglue language in the tech world. And so this is where we're actually going to show you what variables are, what loops are, what functions are, all of that kind of stuff. So if you don't know Python and you want to learn more, that's a good class for you. So these are our classes. We currently do them here in Durham. I'm from Asheville. Hopefully next month we're also going to be starting classes in Asheville. If you want to drive 3.5 hours, that's kind of up to you. So this is here. Again, the in-person classes. So I record all these classes. I'm trying to make the audio better. So these classes are here. So if you miss a class or if you just want to refresh on a class, they should be here. The door should be open. Come on in. Is it not open? Wow. Hey. Yeah, lots of people. We got 2 seats up here, 2 seats back there. Oh, and we got Danielle. Are you Danielle or Danielle W? Danielle. You're just Danielle. And you are? There, cool. Look at that. Or actually, he doesn't want his, so take that book. So these are the in-person classes if you want to take a look at them. We also have fireside chats. So we're going to start doing more of these too. So this is where I sit down and I talk with actual people in the technology world to explain what's going on in the tech world. I do want to actually be starting these with people that are hiring. So since everyone wants jobs nowadays, actually bringing people that are hiring to explain how you get a job with their companies. But anyways, we got the fireside chats there. And if you want self-study classes, we have Introduction to Programming, Python, SQLite, and Bottle Web App Framework. So these are self-study at your own pace. You can take those classes in Silicon Dojo. The big one, again, I don't ask, but there is a donor box link up at the top if you want to throw some money in to make this available, because this does cost me money. I actually come all the way from Asheville to do these classes. So I'm just saying this exists if you want to throw some money in. Hello. Book. I'm sorry, what's your name again? Joan, okay. Yeah. You get to keep the paper, don't keep the binder. Joan, there we go. Okay, so that's about it. So yeah, I'm taking attendance nowadays, just so everybody knows. This is so I start remembering your names, because I have a lot of people to look at, and if I don't start doing this, I will never know any of your names. And also just to keep track of who is actually showing up for classes. And that's about it until we jump into class. Any questions up until this point? No? Okay. You guys are going to be an easy class tonight. Okay, so we're going to be talking about MoonDream, or AI computer vision, basically with MoonDream tonight. And basically, the idea is if we have an image of some sort, we want our little AI project to be able to see the image and be able to tell us information about the image. The thing that is valuable about MoonDream over other vision models out there is that it can give you XY coordinates. This does not seem like an important thing until you need it to be an important thing. And so what we mean by this is, so There's a lava model. There's a lot of other vision models out there. And you can ask the vision model, is there a person in this image? And it'll say yes, or it'll say no. Are there cats? Are there dogs? How many dogs are in this image? And it'll tell you 10 or 20. The thing is, it won't tell you the location of where these things are in the image. So you run into two problems. One problem is if it's erroring out, you have no idea why it's erroring out, right? So if you say, is there a cat in this image? And it says yes, and you look, and there's obviously not a cat in the image. You can't really understand why it's saying there's a cat in the image. And the other thing too is when you start thinking about things like robotics, so especially when we start talking about things like artificial intelligence, we want to be able to interact with the physical world. And so the cool thing is when you have an X, Y coordinate, these are numbers. So X is a horizontal, Y is the vertical. And so what this does is basically you can say, what coordinate do you see a face in this image? And basically if it sees a face off to the side, you can have like a robotic camera, and the camera will then automatically pan or tilt to then actually track whoever it is you're trying to see. So whatever it is, whether it's a person, whether it's a car, any of that type of thing. So you can create robotic things, all of that kind of stuff. Now, when you're dealing with MoonDream is rather slow as far as vision models are concerned. There is a vision framework called OpenCV, which is a lot faster. Incredibly fast. You can actually run it on video streams. The issue with that is that you have to train it on whatever it is you're looking for. So if you want faces, if you want a logo, if you want a car, you actually have to sit down and train the darn thing to actually figure out what those things are. The nice part about MoonDream is you can just say, find this image, and it will find the image. Let me see, where is the... Let me just show you real quick, just so you can get an idea. Lab find things, lab bottle bounty box. So I have a folder full of a bunch of different images with food in it. So what I can do is I can simply say taco here. This is one of the labs we're going to do tonight. It's going to process. Bum, bum, bum. This isn't going to run that fast yet. Come on, you stupid thing. It's normally faster than this. This is one of the things you have to remember whenever you're dealing with AIs. It takes a lot more resources than normal web apps take. So the speed can be a little bit slower than you're expecting. So anyways, okay, so I have all of these images here. I have a folder full of all of these images. Some's burgers, some's fries, some's different things. So I asked for taco. And so what you can see here is it was able to find the tacos in all of these images and then give us bounding boxes around those tacos. And so we can see, and again, we start to have an idea of what it is actually looking at. And that's a valuable thing with MoonDream.
I think it messes sometimes burrito with taco.
Well, it may, and that's where you got to be like, oh yeah, so it thinks that's a taco. And so again, that's where you have to figure out. Remember, with artificial intelligence, the big thing, like whenever I say this, it sounds pedantic, but artificial intelligence is not intelligence. Right? Artificial intelligence, this is simply a marketing term so that Sam Altman can get every dollar out of our pocket he possibly can. All this stuff is exceedingly complicated statistical relationships between things. And so it doesn't see, I don't know, a tortilla with lettuce, tomato, and meat and go, that's a taco. That sees God knows what it actually sees. It just sees statistical relationships in there. And so that's going to be an important thing when you're building your own systems to understand what the failures look like. Okay. Let's see here. So when you run this, just so you know, we'll go over this in a second. When you're doing MoonDream, you're actually going to have to run this as a service. Basically, this starts running on your computer. So you'll install what's called MoonDream Station onto your computer. When you run it, you'll get a little panel that looks like this. When you're going to be connecting to this with curl, I'll show you how to do this in a couple minutes. There we go, going in. The big thing is, so you're going to go to localhost here, :TCP port. This will either be 2020 or 2021. You have to look and see what it says. So when you set this up on your computer, it may say 2020, or it may say 2021, or God knows, it may say something else. When you connect to it, you have to put whatever that number is. So like here, I had this as 2021. In my code, if I put 2020, this thing would just fail the hell out and it wouldn't work. So that's something to keep in mind. Let's see, you. Hey, what's your name again?
Carlo.
And you are?
Derek.
Derek. Carlo and Derek. Derek? Would it be under something else? Free or? Oh,
Free, yeah.
Oh, you're free?
Yep.
Oh, okay. That's that. All right. So anyway, so going to be the big thing when you're dealing with this, do 2021. Also, let's see here. One of the interesting things I found with this particular code, so Bottle is a web app framework that we use for almost everything. I don't know, something seems to have changed in Mac OS, so the operating system. So normally, at the bottom of our Bottle code, just so you know, so this is called a web app framework code. I'll explain this more later in class. But you'll notice down here, we do this run. So this is a run function. Run host equals 127.0.0.1, port equals 8080. So this is what's called a loopback address. It's the IP address. It basically just loops back to your computer and whatever. An interesting thing that I learned the hard way about something with Mac OS is in this code, most of the time you can put in something called localhost. So localhost is a DNS name. The DNS name is supposed to resolve back to 127.0.0.1, and it shouldn't be an issue. When I was creating the projects for this class, all of a sudden my load times or the time to fire the code increased to 30 seconds. So every time I would put in a query, it would take 30 seconds before any of my code fired off. And the reason is, weird crap in the technology world is so 127.0.0.1 is an IPv4 address. So on most computers nowadays, you have two what are called protocols, IPv4 and IPv6. Most of us don't use IPv6. When you put localhost in here and it goes to loopback, it would go to the host file apparently. It would look for the local address in the host file. Since I hadn't bothered to put that in the host file, it would literally be a 30-second timeout till IPv6 failed until it failed back to IPv4. And so that's why we put 127.0.0.1. This is what we're going to do forever now because, again, DNS issues. This is also the thing where, again, technology, a lot of people think technology is hard, like you have to be smart to do technology, and it's really just a lot of these stupid little problems. Like there's a lot of little things that come together to make things work. And again, like with this, you run into weird problems such as what's called DNS resolution that I wasn't even thinking about. So one of the things to consider. Okay, so let's see here. If we go to page number 2, second page. So we're taking a look at this. So this is MoonDream server. This is a MoonDream server. So this is going to be MoonDream server. This is what you will install onto your computer in order to make all the rest of this work. It's weird. A lot of this stuff with MoonDream, again, as I've talked with some people before, a year and a half ago, the software worked really well. Now it does not work so well. One of the problems you're going to deal with in the AI world is none of this is a mature stack. Like whenever you hear Sam Altman or anybody talk about artificial intelligence, they talk about it as if it's what's called a mature stack. Like it's TCP/IP or web servers or that type of thing that we know what's going on. With artificial intelligence, this stuff literally changes by the week sometimes. So what worked last week doesn't necessarily work next week. And so this is something you're going to have to be careful about if you put things into production. Imagine if I used MoonDream last year to build a system, and it's been working perfectly for a year, and nobody's had to mess with it. And then somebody comes in today, and we need to make a small little modification on our code, and as soon as they make the modification, everything goes to hell. And the reason is because in the past year, they've massively changed how their code works, and so even a small change can cause problems. So that is something to consider whenever you're using any of this AI stuff. I've been teaching these classes for 2 or 3 years now. And it sucks. If I create a class on Python, I can create a class on Python, it'll be the same damn class 5 years from now. If I do a class on AI, literally every time I teach it, I have to run through all the code to verify that it'll still work. So that's one of the things to keep in mind. So basically with MoonDream Server now, there's 2 ways you can run MoonDream. They have an API. So this is just a normal API. You connect to their servers online. Your code goes up there. You get back the responses. They give you up to $5 per month for free to connect to their API, which is a hell of a lot of requests. It should be fine for any kind of lab environment. If you want to go past that, you can see what their pricing is. If you're going to run this on their API, the thing to realize is you can run this basically on a potato. Any computer will do. If you have a Raspberry Pi Zero, basically one of these teeny tiny little computers, you can run MoonDream on that because all of the server resources are being run on their systems. So that's the API. I'll show you that in a few minutes. If you're going to try to run this locally, that's when you get into some interesting quirks. So basically, what it appears to be now is that you need CUDA running on it. Apparently, CUDA will now run on AMD if you force it to, so I'm not quite sure about that. But basically, you need NVIDIA, an NVIDIA graphics card, or you need Apple Silicon to make this run properly. If you have any other GPU running on your computer, MoonDream Station may or may not work. So I've tried this. I've tried MoonDream Station on a Raspberry Pi 4 and a Raspberry Pi 5. They fail completely. I've run this on a Jetson Nano, so that's NVIDIA's little thing. You can actually get that to run on that. And then I tried this on a pretty powerful machine that had AMD on it, and that also failed. So it's just kind of one of those, you've got to play with it a little bit. Let's see here. Yeah, oh yeah, and on a MacBook Pro 2012, it also failed. If you're going to install this, basically all you do is you do Python 3 space-m pip install MoonDream-station, and that will install a MoonDream station onto your computer. You then simply run MoonDream-station from the command line, and this will run. So if we take a look at this, powering down. So if I'm at my normal command line here, all you do, hopefully, is you do MoonDream Station. So you don't have to do Python 3 or anything else there. And this should be running. And this will show you it's running. And this will give you your endpoint and all that kind of stuff. So hopefully this will work properly for you. Again, it's one of those things, kind of have fun with it. As far as the labs are concerned, we're going to be doing labs at the end of this. I'll show you where we're going to be pulling information from the web camera. So I'm actually going to have the web camera on here. It's going to take pictures from the web camera and then analyze those pictures. For that, we're going to be using a computer vision framework called OpenCV. So that in order to install OpenCV, again, Python 3-m pip install OpenCV. Any vague questions on that? Hopefully all this will make more sense as we go along. Nope. Okay. So we get over to page 3. What I'm going to tell you is once you go to learn how to use MoonDream, their documentation is hot garbage. Come on. Hello. Wow. We're actually going to have full class today. Your name is? Akash. Cool. I don't know. Find a... shit. Are there seats? No, there's a seat. Wow, the first time we've run out of seats. Look at that. Okay. Yeah, so their documentation is hot garbage. It's not just garbage. It is hot garbage. So again, you may have heard this before. A year and a half ago, they had great software. So they made this modification about a year ago. One of the things, if you go and you take a look at their documentation, it is so bad, their example code doesn't work. So when I was sitting down to write half of this class one day, you know, you sit there with a cup of coffee, you're kind of tired in the morning, so you're like, I'm going to do some easy work. I'm going to copy their demonstration code, I'm going to paste it into VS Code, I'm going to hit go, make sure I have known good, and then we get to play. And then it fails out horribly. It fails out to the point, basically it's saying that you're giving it variables you're not supposed to be giving it. And you're like, but I'm using the demo code. I copy, paste, that's it. So when you go to look at their documentation, just realize there might be a lot of troubleshooting that goes along with it. The next thing is their licensing. So one of the big things to understand, if you guys are going to be a technology professional, a lot of my students groan whenever I talk about this. But a lot of people think when they get to be a technology professional, they're going to be dealing with like Cisco equipment, they're going to be dealing with like high-tech AI and math problems and all that kind of stuff. A lot of what you're going to be dealing with is contracts in terms of services and licensing, and understand how that affects your production environment. And so that's one of the things too with MoonDream, is I'm not quite even sure what's going on with their licensing scheme. Like, there's licensing scheme. I have never seen their licensing scheme before. I had to Google search it. So if we go here, this is apparently, I am informed because I'm reading it, this is something called a business source license. So normally, when you're talking about open source licensing, there's MIT licenses and Apache licenses, and there's copyleft and there's copyright, whatever. This, I don't know what the fuck this is. This is pure misery. So this apparently is from MariaDB. So MariaDB is a fork of something called MySQL from many years ago, when Oracle bought Sun Microsystems that bought MySQL. Anyway, so MariaDB forked off of that. So here, they have come up with this thing called the Business Source License 1.1. The licensor hereby grants you the right to copy, modify, create derivative works, redistribute, and make and this is important, you've got to read this stuff, and make non-production use of the licensed work. So non-production, that means education, that means lab environment. It doesn't necessarily mean going into your systems. The licensor may make an additional use grant above, permitting limited production use. And then it goes into whatever this is. Effective on the change date or the 4th anniversary of the first publicly available distribution of a specific version of the licensed work under this license, whichever comes first, the licensor hereby grants you rights under the terms of the change license and the rights granted in the paragraph above terminate. I don't really know what this means. So anyways, use this in a lab environment. If you go over in Hugging Face, you can go to Hugging Face, and this gives you the additional use case, and this gets to be curious. You come here, so it says, you may make production use of the licensed work, provided your use does not include offering the licensed work to third parties on a hosted or embedded basis in order to compete with M87 Labs' paid versions of the licensed work for purposes of this license. And then it goes through competitive licenses and all of this kind of stuff. So this is, be careful. This is what scares me in Mill, and why I bring up things like Oracle buying Sun Microsystems. So if you're too young to remember this, or you don't remember this whole disaster. So there's a company called Sun Microsystems. They're an amazing company. They created something called the Spark workstations, and they use Unix, Solaris Unix, and they were taking off. They were wonderful. PCs came out, basically they were much cheaper than the computers that they were selling, so they were floundering, so they were trying to figure out what their new product was going to be, and so they decided to be the home of open source. So you had Sun Microsystems go out and they started buying all of the open source projects. They bought OpenOffice, they bought MySQL, they bought a tremendous number of open source projects. And then there's this company called Oracle, which is the truly most evil company we have in the technology world. Everybody thinks Microsoft is evil or Amazon is, no, it's Oracle. They're just so evil, nobody talks about them. And then they bought Sun Microsystems, right? After Sun Microsystems bought all this open source stuff, and a lot of stuff started going to hell after that. And so that's one of the concerns about a product like this, and something to be thinking about, again, in the AI world, is even if the creators of MoonDream are good people and they don't want to screw you over, or if they're just not paying attention to the licensing and they're not hitting you on something, what you have to realize is this might get purchased by somebody in the future. And when that person purchases it in the future, this license will be still attributable to you, and you can get sued from that point in time. So do kind of be careful about that with putting this into production or whatever. Something to consider. So with that, let's get to the actual fun stuff of MoonDream Station. So we take a look at page 4. So a lot of this is things that I've said before. Installing MoonDream Station can be quirky. GPU support is sporadic and poorly documented. Again, Mac OS and M2, it works fine. On Ubuntu Linux Jetson build, you have to run, so I gave you some commands there in order to try to run it. Again, some of this stuff is very quirky. So just kind of keep this in mind if you're going to be running this on your system. How it runs on your system, yeah, might be different. So the next thing here is we can take a look at inference. So what's cool is basically with almost all of these AI things, they're basically, hold on a second. They basically go into a shell. So I'm going to do something here. Okay, so what I'm going to do here, just so you understand what's going on. So I have all of my the files and folders for the class in my little folder called MoonDream class, and I opened up a terminal session here just so I can get to my files easily. So from here, I can do MoonDream station, and this will start my little service. And the cool thing with almost all of these AI products is almost all these AI products give you a shell. So to verify this darn thing is working before you even get to Python, you can run commands against the shell, verify that it is doing what the hell it's supposed to do, and then you can go and start working on Python. So that's going to be one of the big questions, especially when you're new in technology, is understanding where the failure is. Is the failure in the Python code, or is the failure in MoonDream? And again, when you're dealing with MoonDream, it might be MoonDream. So basically from here, you can take a look. If you do help, it'll give you all the commands that are here. And we can do this, inference. Okay, so from here, what we can do is we can actually go into the inference mode right now, and then we can ask it to get some information about a particular image, right? So what I will do is query. So you can do query, caption, detect, or point. We are going to do query here, and I think I have, what was it, picture.png? Picture.png. So I can do query, picture.png, what is this? So basically what I'm doing here is I'm saying what tool do I want to use, what available function. I'm saying what image, so I'm in this folder, so it'll just grab the image that's in this folder, picture.png, and I can simply say, what is this? And I can hit enter. There we go. Yeah. So it tells you how many tokens it took, 104 tokens. It shows you how many tokens per second, 16.3 tokens. So again, something if you're doing this on production, understanding how fast this thing will actually run. And yeah, the image depicts a classroom or training session where a presenter is explaining a concept related to programming, blase, blase, blase. So this is a way that you can run MoonDream Station and again, verify that it's actually doing whatever it is that it's supposed to be doing right here. Let's see here. Yeah, since we're here too, how do I get out of this? Let me just do this. Exit. Okay, so we go to exit. Again, we go to help. So help, it'll give you some things you can take a look at here. So if you want to start or restart the service, you can do this. Inference, you can go to settings. If you want to deal with settings, you can update. If you want to take a look at updates. Sessions, to see what current sessions are going on, or history, like command history. So you can type in history, and this will show you basically all the times that this thing has been queried since I've been playing with it. Kind of give you an idea of what's going on. So all this stuff is here, and this is within the shell if you want to take a look at it. Any questions?
Is that when you were spotting the tacos?
Oh yeah, that's probably when I was spotting the tacos. Yep. Yeah, so yeah, taco. Yeah, detect. Or no. Oh yeah, because I was using detect. Yeah, so yeah, that's when I was looking for the tacos. Yep. You can do session. They also give you like a session ID. It'll tell you how long this thing has been up and running, what model you're using, the port you're using, some of this other information here. So this is the basic idea of how this is running. Let's see here. All right.
When you restart, does that create a new session?
Yeah, so as you can see, this is only running for 3 minutes and 30 seconds. So that's when I actually started it. Yeah. That's going to be the other thing too, is for anybody who does system administration work, if you're going to put this on a server, do remember if you have a power outage and your server boots up again, if you do not auto restart the service, then everything's going to fail out and break. So again, one thing to keep in mind. Okay, so now let's go and start looking at the actual Python code. Let's see, moon caption. There we go. Okay, so this is going to be what our code is going to look like. As I said before, the documentation for MoonDream is garbage. So there's a way that you're supposed to use the MoonDream module. So there's actually a MoonDream module that you can install into your Python environment. You're supposed to be able to just call the MoonDream module and it's supposed to work. It just doesn't. It just doesn't. So to get around that, we are going to use something called the requests module. So the request module is a way to interact with URLs, basically. And we are going to use something called curl. So curl is used in the web world, basically be able to send things like files and images, essentially using a URL. So that's what we're going to be doing here. So one of the weird things with this is even though this code is on this computer and MoonDream is on this computer, we have to design this as if they're entirely different systems. Just kind of weird how it works. And that's why we're going to be importing what's called the base64 function or module. So what we're going to do here is we have the picture.png file. So we're going to say with open picture.png, open it as binary. RB is for binary as F. And then what we're going to do is image underscore b64 equals base 64.encode.read.decode. And what this is going to do is this is going to turn this image into a binary file that we can actually send up with curl. Just one of those weird things you have to do. Basically, copy and paste. Copy and paste. So payload here is what we're going to say is payload equals image URL. As we're going to say, this is going to be data. It's going to be an image. And it's going to be this file that we just created. We then create our little requests. So this is using the request module. We're going to post. So post is sending to the server. So we're going to do HTTP localhost at 2021. So this port will be whatever is on your computer. If it's 2020, it's 2020, 2021, v1, and then there's a caption. So when I was showing you those different functions that were available, there was detect, there was caption, that type of thing. So for this, we are just going to want a caption. We're going to send JSON equals payload. So this payload is going to go up. And then here is what's called a method. So when the value comes back, we want to turn this into a JSON value so we can grab an actual index from it. So response is going to come back, and then we're simply going to print out response is caption. So what this is going to do is it's going to look at this picture. It's going to create a caption for us, and then we're simply going to print out the caption on the screen. If this does not go poorly, we're going to run this. Come on, give me a caption. There we go. We got a caption. A man in a green shirt stands in front of a whiteboard, gesturing as he presents to a group of people separated at desks. The whiteboard displays diagrams and text to software development, including user and API, laptops are open, so on and so forth. So basically, this might be a good way if you just have a lot of images and you want to get just basic information about those particular images. You can just simply use this caption function. You don't have to ask it any questions. You don't have to give it any additional parameters. It will just go through and pull out or create these little captions for you. Does that all make sense to everybody?
The caption has been taken from the URL.
What's that?
The caption word. So the response is created, right?
Yes.
How the caption is created.
So basically, that's what happens here, right? So when we post, so to localhost 2021 caption, and then we send up this payload. So all of this is going to be going to MoonDream. Because we put caption in the URL, MoonDream knows all we want is a caption. We don't want anything else. And so what is going to happen is MoonDream is simply going to send back the caption that it creates. And since this is in JSON, then the index will be at caption. So that's what's happening there. Like if we just do response, again, this is where we'll have a full day class on Python in January. So we just do response without putting the index in, just so you all understand. basically what we can see here is so this is the caption. So caption, and we got the caption here, and then we can also get additional information out, such as the tokens, the duration, how long it took for this thing to run, and tokens per second. So this is the full response that's coming back from MoonDream. I'm just pulling out the caption for that.
Can you like modify that voice, or is the caption like built in?
The caption is just built in. You can't work with it at all. Yeah. So you can do query. So I'm going to show you how to do query. Query is where you can actually ask it questions and try to change things around. Yeah. Any questions about caption? Yeah. All right. So then query, yeah, that's where you get to actually play around a little bit and have some fun. Moon query. So we are on page 7 at this point. So it looks a lot the same like we were doing before. So we have the base64 module, the request module. We're encoding picture.png just like we did before. The difference here is going to be a payload. So payload now equals, and we have the image URL, the image that we're sending up, and then we can have a question here. What is in this image, right? Or whatever question you want to have. And then down here, the important thing you're going to look for is now we're going to query. So before we were going to the URL caption, now we're going to go to the URL query. Everything else is basically the same. When we get the response back for this, though, we're going to go to the index of answer. So when I run this is going to give me something that looks a lot like caption, but it's my particular question. So again, so this is what is in the image, so it gives me the description what's in the image. What gets really cool about query, and I'll show you this in our lab where we have a little security system, is I can say, is there a person in a green shirt?
Can you say like reply in poem form or something like that, or is that not?
That's not this. Yeah. So what you could do there, and again, this is one of the big things that IBM talks about a lot, is you can stack LLMs or models. So you could have this provide a response and then send that response to like a text LLM and say, put this in Shakespearean verse. That's what you would do. Yeah. And so yeah, so here, yes, there's a person in a green shirt standing in the front of a whiteboard. And what gets interesting here is, again, remember, talking about this old XY thing that we'll get to in a few minutes. But remember, whenever you're writing code, you need your code to be able to read these responses. You need to get back, normally it's called structured data. What can I actually trigger against, right? What response can I get back where I can then fire an event based off of what it's saying? So what's kind of interesting here, I can say, is there a person in a green shirt? Answer, yes. Or no only. Hopefully this will work. There we go. So now it responds only with yes. And the important thing is, right, so if we're doing taxonomy, if I'm simply scanning through a whole bunch of images and I'm just adding descriptions to those images, again, I don't need structured data to do that, whatever. The important thing is, what if I want to trigger based off of whether there's something in there? Like every image with somebody that looks like this, I want to move that image into a different folder. I'm going to need something a lot clearer than 30 words that explain it. I just need a yes or a no. And so what I can do is response equals yes, do this, else do something else. And so that's one of the cool things with MoonDream Station is you can start getting back these kinds of responses. Yep.
So this model has a classification and also reasoning.
I don't think it has reasoning.
So the one which you did is a little bit of reasoning, right?
Seems like a reason.
Yeah, we get into these models. Yes, no, maybe. I don't think MoonDream does reasoning.
So what did it do? Just check the caption for the word green and shirt?
You just issued an LLM like kind of.
Does MoonDream have? I don't know. We will Google search that later. I do not believe MoonDream has reasoning.
You guys talking about like spatial relationships? Like
does it know to answer a question?
Yeah. I don't know. We will talk about that after class. I'm not quite sure. So with these different models, so there's reasoning models, there's a lot of different models out there, and again, this is the thing being a teacher sometimes. I didn't research that one first. I'm not sure if this is reasoning. I don't think it is reasoning though. I'd have to verify on that. The important thing is we can get yes or no's out of here. Any other questions? Oh, it's always.
It didn't say how many tokens it used. Right?
Well, because so if we did the whole response.
Oh, it was okay.
Yeah, so I do the response. So that's like I say, when we're pulling out the JSON, I can get that specific thing. So answer yes, tokens 1, duration 3 seconds.
Gotcha.
Yeah. Okay, then beyond that, so that's query. Then we can get to detect. So detect is going to give us basically the X minimum, the X maximum, the Y minimum, and the Y maximum. So what that means is so if we have a picture, and let's say it has faces in it, and I want to say, where is the blue face? So I want to do detect, and I want to see where the blue face is. So what it's going to do is essentially it's going to figure out what the bounding box of this should be. It will give me the X minimum, the X maximum, the so X is this way. Then going down, it will give me the Y minimum and the Y maximum. So basically, this will give you the parameters of where the particular item is found within the image. So if we go take a look.
Why be from the bottom or from the top?
From the top. From the top. See, he's got me all worried now. It's from the top. It's from the top. So we take a look at the detect. And this is going to be in percentages too. It's going to be in percentages. So if we go take a look, again, we're on page 7 of 24, Moon Detect. So this is going to be the same image, picture.png, and so you know what that looks like. Again, picture.png, there we go. So I'm going to run Moon Detect, and I'm going to look for faces. So this is going to show me when this comes back. So objects, and then it's going to be a list. So square brackets, these are indexes going from 0, numeric indexes. So the first xmin, xmin, ymin, xmax, ymax, it only found 1. And so if we take a look at the image itself.
Isn't going to be consistent across rounds for the same image or not?
It should be relatively consistent. I have not had a problem with specific consistency. Okay, so there we go. So if we take a look at this, right, this is about halfway through. So if we look at xmin, so xmin is coming this way, so it's at 0.49%. So about 49% is there. If we look at xmax, it's at about 53%, which is probably about there. If we look at ymin, is 34% down. So if you look at this, again, it's coming down. So it's 34% down is the top of my head. And if we look at ymax, is 44% down. So again, that's about correct. Yeah. And again, that's one thing where you can run these. Again, we'll have the labs where we'll actually be creating little bounding boxes, and so you can see this specifically and how it is. Again, how what is the word for it?
Reliable?
Reliable? Well, no, it's reliable. It's how, will it always provide you the exact same number? I probably wouldn't bet on that one, but you can test that out yourself.
Because I'm
Yep.
looking at an example on the spreadsheet that there's different numbers.
Oh, does it show you different numbers? 490, 4977. Yeah, so that's, again, good enough. So that's the so the caption, query, and detect. Any questions on that?
So this gives the coordinates in terms of percentages, not exactly the pixel.
Yeah, so it'll give you percentages across, yeah. And so that's where, like when we do the labs later, what's nice with CSS is you can do percentages in CSS. If you use something else to create bounding boxes, like OpenCV, you can actually put bounding boxes within OpenCV itself, and so you have to verify what you're doing there. Because one of the things, again, that's with programming, with any of this stuff, again, it's all little things that build on each other. So let's say what you're using, you have to know the pixels in order to put the bounding box. Then what you might need to do is you use like the pillow module. And so with the pillow module, you can actually get the pixel height and width of an image. You then take the percentages, multiply times that to give you the pixel location. And so that's where you kind of like have to build to get to where you're going with whatever product is you're using.
So when you said the documentation was terrible,
Yeah.
that was for the MoonDream module.
Yeah. And so basically, so all of this is I kind of had to create this.
So basically what you did was you know what the functions are, and you just went through each one and tried to figure out what it was doing.
Yeah, basically. Yeah. Okay. So this is all running locally, and again, hopefully it'll work on your system. Then we get to the API. So when we talk about the API, this is actually running up on their servers. So you can go to moondream.ai. It'll bring you to this nice, pretty page. I wish they did this much effort on their documentation. You can come here to pricing. So again, this is one of the things to realize. So this is a product that they're trying to sell. Again, one of the reasons why you have to be concerned about their licensing scheme. So you get $5, again, $5 in credits free every month to jumpstart your experiments, which is a lot. For your lab environment, it's fine. Beyond that, then you get in this thing like 30 cents per million input tokens and $2.50 per million output tokens. This is where you're going to have to take a look and probably document how many tokens you're using every time an image gets processed, and then think about what that means at production scale. So if you have one security camera that's running against their API, it's probably not going to cost you a lot of money per month. If you decide to scale out and you have 1,000 cameras all pinging their API every 3 seconds, that might end up being a lot of money pretty quickly. So that's just one of those things to be careful about. And again, with all of these AI companies, I call this obfuscation. Basically what they're doing here is they're not telling you how much it costs per image. They're telling you how much it costs per token, and every image is a certain amount of tokens. So it can be very difficult to understand what the bill at the end of the month is actually going to be, so be very careful about that.
But a bigger image would have more tokens.
Yeah. What's that?
Do they do like any image kind of shrinking, resizing before doing anything?
As far as I know, they don't. You could do something, but as far as I know, they don't. If we go here again, once you go into their little API panel, you'll see it's incredibly simple. So we can come here to like API keys. So this will show you your usage. So again, I have to use like 2,400 tokens. It says 3 requests. I think that must be for today. It shows me the different requests that I've done. So each one of these images that I've processed using their API, so it's 0.00, so that's cents. It is 0.041 of a penny per image processed. So multiply that times however many images you want to process, and that gets to real money. So anyways, this can show you what your token usage actually is and the rest of it. You come up here to the API keys, and this is just a pretty simple system. So this is the API key that I'm using. You want to create a new API key, you do this. Make sure to copy your API key, and then done.
You didn't get the period you wanted there?
Well, it should have. Anyways,
I don't know
it
if
should
you
be
need it
fine.
or not.
Yeah.
But
So anyways, these will be the API keys for you. I think with this, what's interesting is, yeah, you can actually see your API key after it's been created. So this is going to be one of those things when you're building your software, is sometimes when you create API keys with different vendors, once you create the API key, there's no way to get it back. This company, they actually allow you to get it back, which is one of those random things to think about. Do remember, after you do a class where you videotape this and show this to the entire world, make sure that you delete your API keys. Okay, so beyond that, we go to API usage, so Moon API.
So wait, all the image processing is happening on the cloud?
So when you use the API, it is. So the last examples I showed you are here.
Local machine.
This is going to be up in the cloud. And so that's why you can use a Raspberry Pi or whatever to use this type of thing. Yeah. And I do wonder, again, that's where you have to think about like with business things, since they do want this to be a business and they want somebody to buy them at a certain point in time. Since all of this could run on things like Raspberry Pis before, it does make you wonder if they modified your code to force certain systems to start using their thing, to basically force utilization. But we go here, and it's pretty simple. So Moon API. So again, we got a big old API key here. Again, don't publish this to YouTube unless you're me. Anyways, so here, this is where we're going to actually import the MoonDream module. So this is the Python module itself. So you do pip install MoonDream, and this will install the MoonDream module. So you have MoonDream Station, that's a server service, and then you have the MoonDream module. So this is where you can do that. As MD, this is just what they do. So I'm basically copying and pasting this code. And then we're going to do from pillow import image. And so basically with this, is what we can do is we can use this pillow module to deal with the image instead of that base 64 thing that we were doing before. So my key is going to equal the key as it is. And this is all pretty simple. So model equals this, API key equals the key, image equals image.open picture, and then we simply do result equals model.caption image length normal. So I just want a normal length of the caption, and we're going to print out results. So basically, this is all we need in order to actually connect with the API. And so when we do this, it should be a lot faster. Should be. There we go. A little bit faster. And so now it's giving us, again, a caption of the exact same image. The difference here now is that this is coming from their servers, not from your machine. And then with this, they have the same thing. They have detect and they have query, and they have that other functionality if you want to use it. Any questions? No? All right. Cool. Now we get to start getting to some fun stuff. So in order to get the fun stuff, we have to bring in another framework. Moon Webcam.
So I have a question.
Yep.
So this detect object.
I'm sorry, where are we at?
Sorry, the page 8.
Page.
The detect model here. The detect.
Yep.
So are there predefined types like faces?
Wait a minute, you're
or
not-
you can give anything.
You're not on page 8.
Page 8.
This is page 7 for us.
Detect.
Are my pages different than you?
Your
This is
page
page
7
8
is our page 8.
Oh, nobody told me
There's a
that.
blank page for some reason.
Are you serious?
Yeah.
Seven.
Oh, yeah.
Page 7 is blank.
What the hell? Okay, so 7 then. Okay, detect.
Do you wanna?
Yeah, no, okay, no, that's there then. Okay.
Just +1.
Computers. Anyways, yeah. Okay, cool. Yes. Okay. Page 7, detect. Yes. Yeah.
Yeah, faces. Is that a keyword and predefined objects that you can detect, or that can be anything you can do, like, find my grandma?
No, yeah, you can put in mug, you can put in picture, you can put in middle-aged guy. So yeah, it's not a specific keyword. It's so like if we go, oops, what is it? Moon detect, right? And let's see, where's that image again? Picture.png, right? So yeah, so I could say, I don't know, hat. So then it gives me at 0.41 and 0.60. So let's see here. Yeah, oops. Oh, my, shrink down. So I've got a hat there. So I don't know, 0.41 and 0.60. That's about where a hat would be.
So it didn't capture the hat on the right.
Yeah, it didn't capture that hat. Yep.
But you said hat, right?
Well, no, but it'll come back with multiple.
But you said faces here. Are you sure you don't need to make it plural? Hats?
We will. You're the student. We'll do hats. I don't think. God knows. This is where you hate being a teacher sometimes. I don't think
it's
so.
not a hat, though, is it? I guess it is a hat.
Yeah, no, it only brings back one. So I could do, let's say, head.
Or heads.
Yeah.
Right, Right. So
There we
this
go.
is a better test.
There we go. Yeah. So see
It doesn't
that.
have to be plural.
Yeah, it doesn't have to be plural. So yeah, those are multiple heads that pop
So
up.
did they give any ability to fine tune their model to have a better detection?
As far as I know, no.
And I guess if you specify something that's not in the picture, it just returns empty.
Yeah. So if I said
Taco.
plane, okay, I'll do taco. We'll do taco. Taco on the moon. Is there a taco? Yeah, there we go. Nothing. Yep. Cool. Okay. So then we go. Oh, any other? Yes.
Yes. Typically, how often or how many tokens to an image, roughly speaking, do you normally with MoonDream? How many tokens will an image, one query for one image consume? Do you have an idea?
I'm honestly not sure. Like I said, I just play around, especially since it's running on my machine. I don't normally pay attention to it, so that would just be for something for you to track.
Basic
Yeah.
extraction from the cost, average cost of 0.04 cents, and then just your cost per million tokens, right? You just-
Yeah, you could do that. Or yeah. The other thing is, but like with the tokens, it's going to have to be like what is the resolution, like what is the size. So if you have a large image that's high resolution, it's going to cost you more than a small image with low resolution. So that's where you got to play around with it.
So depending on what you want to do, you could like optimize your images a lot for
Yeah.
depending what kind of question you're asking.
Yeah, so like if you're going to be sending up to the API, and that's where, again, I talk about architecture a lot. So I'm an old school systems guy. I got my MCSE back in NT 4.0, so I love architecture. And that's what you have to think about, like at scale, right? So if all you're going to do is you're going to run 10 images through MoonDream, then you're not going to worry about architecture. You're just going to run the images. But think about it. If you've got 1 million images, let's say you're the equivalent of Instagram and you want to auto tag images, it might be worth it to use something like FFmpeg and basically have a pre-processing thing that shrinks the images down, then sends the images to MoonDream, and then you take the tags and relate that back to the original image. But again, it's going to be that whole thing of is it worth the time to code and create that type of system? Yeah. Any more?
So, yeah, image unit size. When the size is when we're uploading images.
Yeah. Yeah, so you don't get really big ones. Yep.
So is there any information on what data it is being trained on, like the MoonDream?
They don't tell you that. They don't tell you that. Yeah.
So it typically works for any of for example, if there's something like a plant or whatever, we just know that it's working if you try it. Then?
Yeah, so that's basically where you test it. That's one of the reasons why I talk a lot about IBM's Granite models. And one of the reasons why I like IBM Granite is they actually tell you what the hell this crap was trained on. So actually, if you look, I did a fireside chat with literally the VP of AI models for IBM. And one of the things we discussed is they will point you back to everything they train their models on. So they can't give you a data store of that because of copyright issues, but they'll point you to it. The issue with so many of these models, they probably didn't do this shit legally, frankly, right? So if they told you what they pointed back to, they could get sued. And so how our legal system works is you have to prove that they did something wrong. So they don't want to hand you that evidence. So I can't tell you what they did was incorrect, but as far as I can tell, I don't know what the hell they trained these things on. Yeah. Any more questions? No? Okay, so let's get to actually getting to some of the fun stuff. So Moon Webcam. Okay, so this is going to be one of the questions is how do you pull information in to your project, especially when we're doing computer vision. So let's say we have IoT, Internet of Things devices, things like security cameras or robots or whatever else. One of the big questions is how do we pull actual information into MoonDream in a real-time fashion so that it can process. So there's something called OpenCV. We'll have a class on this later. And OpenCV is a computer vision module, computer vision framework that you can use for Python, which allows you to do a lot of really cool things. One of the very simple things that it can do is it can actually just simply capture images from your webcam. So basically you can plug a webcam into your computer, you can then pull images directly in from the webcam, and then you can process those images using MoonDream. So basically with this, all this is just a very simple piece of code just to show you how you can pull images in. If we take a look at this, so you have to install the OpenCV framework. So pip install OpenCV-Python. We're then going to do import CV2 as CV. One of the things you'll notice sometimes, there's a lot of copy and paste in the computer world. I don't really know why we bother with this. I mean, don't get me wrong. If this said like OpenCV computer vision as CV, I'd understand that. It's CV2 as CV. So all this is an alias. So if you don't know in Python, this is just an alias. So we're going to use this to designate this. I don't know why. We just copy and paste it. Anyways, I'm then going to import time here. We're going to use this down. We're going to sleep for half a second down here. Because one of the interesting things with OpenCV is it will capture the webcam image, but many times it'll capture it so quickly, the camera is not on long enough to be able to get a good image, so your image will be incredibly dark. So let me just do this for a second. So basically, right here, we're going to say cam equals cv.videoCapture1. So this is going to be the number of your webcam. So for most of you, this number should actually be 0. So again, remember the computer world numbering generally starts at 0, 0, 1, 2, 3, 4, 5, 6. So your camera should be 0. This is Mac, so they do things their own way. So because of, what is it called, continuity, my phone can be a webcam for my Mac. So 0 actually connects to my phone, not to the physical webcam. So that's why I have to put 1 here. 1, that's actually the second webcam as far as this computer is concerned. So I took out time.sleep here. So let me just run this for a second. And basically, okay, well, that's going to be really dark for you. That's what you get. Oh, I can see me. Can you see me? If you look really hard, right? And this is what you're going, if you do not slow down this script, it is going to take a picture, but it's going to be this dark, which is basically worthless. So, kill that. So that's where, just so you understand, that's why we put the time in there. Hit run. And simply by, there we go, oh, my beautiful picture. Simply by delaying this thing by half a second, we actually get a picture that is usable. So again, this is the weird kind of stuff you have to worry about with the coding.
Is the dark image actually like that other one not usable by MoonDream? It wouldn't be able to process that?
It would process it to the degree that it is. So you could still kind of see me there, but it's going to be harder for it to process. This is going to be a hell of a lot easier for it to process. Yeah. And also for you, just to take a look at it to see what it's seeing. Yeah. So that's basically why we bring this time.sleep in here. Then we're just simply going to capture one frame. Again, this is a lot of capture, copy and paste stuff. Frame equals camera read function. So if we return something, image show, it's going to say captured. So this is going to be the title for that image that we're seeing. Image.write, this is going to be the name of the image that we're going to save. So captured underscore image.png. So you could have your own naming convention here to name this image whatever you want, especially if you want to save images. So if I want to save a series of images, I would come up with a system to save a series. And then I'm just simply taking the frame. So the frame is that one single frame in the video feed. It's just grabbing that and it's saving that. And then basically this is for destroying the window. And then if all this fails, it simply says fail to capture the image. And then we release the camera. So with a lot of these things, do remember in the programming world, make sure to release. So close your database connection, close your camera connection, or you can run into all kinds of less than fun problems. And so basically all this code is doing for us right now is it's simply getting us that particular image. There we go. And the important thing there is so the image show, that's where it's showing us. But the important thing is I now have that captured image in my folder, so I can now process against it. Okay, so all kind of sort of makes sense? Cool. Okay. Then we are going to go to my page 10, whatever the hell page it is. What do you see? We're going to go to what do you see? So with this, we can literally just ask it a question. Okay, so this is where we start creating our little functions. So again, if you're new to the programming world, basically functions are kind of like little programs within our larger program. It allows us to very easily reuse the code that we've created. So we take a look at this. So we're going to have OpenCV, we're going to have time, we're going to have base64, and we're going to have requests. So this is going to allow us to grab something from our webcam. This is going to make sure the image is a quality we care about. This is going to allow us to upload the image, encode the image, and then this is going to use requests to actually send the image to MoonDream. Again, do make sure that MoonDream is working. One thing, if you actually know coding, if you know Python, and you look at my code, and you're like, Eli, why aren't there try except statements in any of this? One of the things when I'm teaching you folks is I try to strip out all the code that you don't need to understand what we're discussing. And so a lot of times people put in basically code, failover code and checking code and that type of thing. And I kind of strip that out just to make it easier for you guys to understand what's going on. So again, if you're putting this into the production world, if you know what a try except statement is, put that in there. If you don't know what it is, we have a class on Python coming up in January. Okay, so what we're going to do here is we're going to do a while true loop. So a while true loop is just a continuous loop. Be careful with these. So query equals input, the input function question. So this is where we're going to simply ask a question. What question do we want to ask of MoonDream? Then we're going to do image equals camera. So we're going to go and we're going to take a picture, right? So basically with this, we're going to go up to this camera function. So we're going to do, video capture 1 or 0 for you guys. We're going to do the sleep. We're going to capture the image. Same type of thing. And then what we're going to do is we're going to return the image name. So the image name is here. This is what we create, and we want to return that image name. So what we're doing is we're firing the camera, and then we're returning the image name. Then response is going to equal to the AI function. We're going to send query, and we're going to send the image. So what we asked here, along with the image name, that is going to go to the AI function. All right, so this is where we turn it into a base64. This is then the payload, so the image that we the encoded and the query, whatever question we're asking. This here is then where we're going to send this to MoonDream. So localhost 2020, query, payload, come back in a JSON format, and then we're going to return response and answer. So basically we get that JSON response back, we just want the answer value. So I can say, I don't know, question. Let's ask me, what mood is this person in?
I think it already got the image.
There we go. The person in the image appears to be in a mood of anger, and frustration is indicated by their facial expression. Right? Is this person happy? There you go. Yes, this person is smiling and giving 2 thumbs up, right? Oh, well, I'm not sure you'd say that. What is this person wearing? This person is wearing a green t-shirt. Right, so basically this is a way to show you this is dynamically taking an image from our webcam. We're sending that image along with a query, and then it's able to give us an answer back. So that's basically what this little lab is trying to do. Is there any questions about this lab? No? All right. Yep.
Sorry. Can you ask the question to point to a certain place in the image and ask the question? Like, for example, so if it is taking your picture there,
Yep.
can you ask that to, what is on the board instead of you? Something it does.
Yeah, I can say, let's see what time. What is on the whiteboard? Whiteboard has a simple drawing that appears to be a diagram, possibly representing a flowchart or a simple representation of a tree.
So you took a picture of both you and that
one. Well, so it's taking a picture from the webcam. So,
oh, okay.
yeah, so that's, Oh, I need to lay off the. Anyways. So yeah, so it's taking an image, and so I asked the whiteboard, so it was able to understand that this is a whiteboard and try to figure out what the hell that means. Yeah. So I mean, like, yeah. So I mean, we could say, let's try to be a little easier on it. No, we're not gonna be harder. Let's see. Let's see. I don't know.
Can you put like a number and see if it can like figure out what the number is?
Let's see here. What the hell is that lab? MoonDream webcam describe. Oops. What number? Shit. What number is on? Boop. 4. What is on, though? Yeah, so it's surprisingly accurate. This is all running locally. There's a drawing of a tree on the whiteboard. So yeah, you could tell that that's a tree. So again, yeah, not too bad for what it is. Any other questions with this? Yep.
For the one that you just showed, if we want to use the API, would we still use model.caption? Is that the function?
No, so this would be query.
Query?
This is query, yeah. So caption just spits out just a caption. So it just fires off. You don't get to do anything. You don't get to ask it anything. Query is where you actually get to ask it things. Yep.
And what is, well, I'll just go ahead and answer. What would be the parameters?
For what? What's that?
Like here I have model.caption given an image and length. So what would you send to the function if it's model.query?
So if it's an API, so that, where's the API? Okay. So yeah, the documentation.
Can't get the model to run locally. So.
Getting started. So to tag, okay, so query. Yeah, so this, yeah, so on the API, this should work. So that's where your API key goes. This is your image path, and then this is what your query is. So you would just wrap that into a function instead of what I have.
Okay.
Yep.
But the documentation's not too bad.
Well, you're nicer than I am. You're nicer. Yep. Okay. Then the next thing we get into is we start to actually do something that might, in fact, be useful, real products in the real world. This is going to be one of the big things to be thinking about. Again, we start talking about artificial intelligence, is everybody wants to use AI. Like you hear Meta, you hear all these companies, they are forcing their employees to use AI. What you'll notice is they're not really telling them what they're supposed to be using AI for. They're not like, we want to use AI to decrease bugs, or we want to use AI to increase the speed of fixing bugs. They're just saying use AI. So a big thing that you need to be thinking about is what the hell are you going to be using artificial intelligence for? And so with this next series of labs, what I'm going to be showing you how to do is basically how to pull information from something like a driver's license. So imagine you go into a doctor's office. Instead of having to fill out all this information, you can simply put your driver's license under a camera. It takes the pictures of the driver's license and then can auto-fill out a form for you, right? How easy is that? And this system actually can do this relatively simply. So if we look at this, my page 12, so lab ID. If we take a look at this, basically I've got a couple of IDs here, PNG files. So these are fake IDs. I asked for fake IDs and they gave me fake IDs. So John sample gives an address here, date of birth, that type of thing. And then we have ID 2 for this lovely lady, Jones, Angelina, Gabriella, blase blase. So again, imagine being able to just be able to pull this information. That's what we're going to be doing with this. So Moon Lab ID. Okay, so this is the code. And again, as I will keep saying with all this stuff in technology, it's all so simple. So what we're going to be doing here is we're going to do we need JSON? Oh yeah, JSON loads. Oh yeah, that's fine. Okay, so what we're going to do here is base64 like we did before. We're going to import requests. And we're going to import JSON. The reason we have to import JSON is, again, this is a little weird thing with data types. So the response that comes back from MoonDream is going to be on JSON. But the value within the index that we pull out is going to be a string value, even if we ask it to be formatted in JSON. So we have to have the right data type. So why we're using the JSON module is we're going to get the response back from MoonDream. We're going to pull out the value from a specific index. We then have to turn that value into JSON so that we can pull out the individual values from that string that we got back. So basically, when we take a look at this with open, id2.png like we did before, and we encode it. We come down here, image URL like we did before. And this is where we start talking about things like prompt engineering, figuring out how to ask the question so this damn thing gives you the answer that you want it to give you, because sometimes it's just a pain in the butt. So what we're going to say is return first name, last name, date of birth, and driver's license number in JSON format. And then we are going to give an example of what this JSON format should look like. Originally, when I did this code, and again, this is where what we call prompt engineering, and this is a lot of testing and banging your head against the walls. It gives you stupid crap. So originally, I gave it examples. So like Bob, Smith, a date of birth, and driver's license. What I found, for some reason, it would start auto-populating with the crap that I put in here for some reason. So literally giving it blanks as values actually works better than giving it an example as value. Again, weird kind of stuff that you have to test for. So this is going to come back as JSON, as we've done before. So we're going to print out response and answer. And so that's going to be that full text, the full string response that comes back. So it's going to look like JSON, but it's actually a data type of string. Ergo, you can't actually pull key values out of it. So then we're going to say data equals JSON.loads, that answer. So this is going to turn that answer into JSON. And then we're going to print out data first, data last, and data date of birth, and data driver's license. So if we go and we take a look at this, basically run this against ID2. So this is the value that's going to come back. First, Angelina, last, Gabriella, date of birth, and driver's license. I do believe these are correct. And then this is where we actually pull them out as individual key values. Yep. Well, yeah. So that's where we're going to get in. We're going to keep building on this lab to show you how to like modify things. So yeah, so that's the weird thing. Again, like you look at IDs, and again, if we look at this guy, right, John Sample. So John Sample, first name, last name. Again, with her, this is where you get into weird thing. So up here, it's family name, and then down here, it's given names. And again, that's one of the things you have to be thinking about with these AI systems is how can you have some kind of manual process in there to just tweak things if they're slightly different than you think they're going to be. Any other questions? All right. Then we get to the webcam and the ID. So basically what we're going to do here, again, let's see how this works. Come on, work for me. So lab web ID. Okay, so if I run this, I'm going to put this person here. So take, it's going to get a green camera. That's done. There we go. So basically, we just got my little driver's license here. First name John, last name Sample, date of birth 1/12/67. Yep, 1/12/67, and driver's license is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the cool thing here is we take a look at the captured image. So that was the captured image. So I was able to just put this in front of the camera. It was able to grab that and be able to pull the information out. Basically, again, we're simply building on the things that we did before. So all we're doing is what we did before. We're just simply adding the camera function. So again, we have OpenCV, we have time, we have base64, we have requests, and we have JSON. So here, what we're going to do is when we run this, image equals camera. So that's basically what we did before. We're just simply taking an image from we're taking a frame from the camera. We're returning the image name, and that's coming down here. Response equals AI image. So then we go to AI function. We're going to send the image up, and then we're going to give it the prompt that we did before. We're then going to get this response back. Then we're going to JSON loads the response, and then we're going to print out the information. So basically that's where we go from OpenCV, then we're going to send it to MoonDream, then we're going to get the answer back, then we're going to print out the values.
And this is all local.
This is all local. Yep. So, and again, like I say, it's all relatively fast too. So again, if we do her, so Mary Washington, what the fuck? You know, but I wonder, I bet you, no, I actually did the picture. Huh.
Where do you get married from?
Yeah, like I say, it's whatever it is not intelligent. It is just not intelligent.
Can I see the picture it took?
Yeah. Oh, come on, what's going on with you now? Come on.
The resolution will act up because it was looking at my last name as Walton and going Watson and, you know, every other permutation of it but Walton.
Maybe it just has to be closer. I mean, let me do it closer here. Yeah, again, this is one of those things. And this is where you have to think about like artificial intelligence, also the physical things that are going on. Like how do you make sure that the person, yeah, okay, there we go. I guess it was in there. So first, Angelina, oh, that is correct. Last name, Gabrielle, that is incorrect. Date of birth, 2018. Yeah, that's the expiration. And driver's license is correct. Anyways.
I guess you could put in a line though saying, is this readable? How would you rate this, the readability, and then keep on looping until it it's readable.
You could.
What's high readability?
Or basically what we're going to do is we're going to do what we're going to do next. You'll see the next thing. So we're building it. That's whenever I do these things, I'm trying to build up to where we're kind of going towards. All right.
Show us the magic.
Oh, your magic. Yeah.
Because you kind of all you really did for the last name is say last name. Like,
yeah.
Could you say like give me the last / family name? Would it like be able to figure something like that out?
That's one of those you play around with. Because the other thing too is you have to realize again. I'm only doing 2 IDs. We've got 50 states, plus God knows how many other IDs. So that's where you've also got to play around with exactly. Because MoonDream, you can't be complex with MoonDream. You can give it like 2 sentences and it's good. Like once you start getting much past 2 sentences, it starts getting a little bit wonky. Yeah.
So this reminds me my bank where I deposit the check. Right?
Yep.
So I have mobile app on the camera.
Yep.
I take the picture of the check.
Yep.
And while I'm taking the picture of the check, it will ask me to adjust the camera so that it can take a clear picture.
Okay, yeah.
So that way the model can, identify things correctly. So is this OpenCV, does it have any mechanism to guide the user to take a sharp picture?
See, that's where, again, you build. So OpenCV doesn't, or I don't believe it does. What you might do with something like this system is like with MoonDream. Basically, you would say with the detect, give me the X, Y minimum maximum of the ID. If the ID is smaller than whatever, then ask user to put ID closer. And that's where, like I say, that's where I keep saying this stuff is simple. You just keep building simple things on top of each other. So like if I was going to be using MoonDream, that's what I would do is I would say find the ID and detect the ID, and then I would look at the size of it, and if it was too small, then I would say please put it closer. That's what I would do. Yeah. Yep.
Does it give anything like a confidence metric or anything like that?
This doesn't. No. Okay, so then we get to the next part. And again, this makes this stuff a little bit easier for you. So what we do here, and this is where I found out the disaster of DNS resolution. Okay, so this is going to be a bottle web app. So Bottle is what's called a web app framework. This allows us to create web applications in Python. It's incredibly simple. Just to be clear, Django is a much better web app framework. It would also take me a night just to explain how it works before we even get into it. So Bottle is really nice. You get just write a little bit of code and it runs. So we see here it says listening on 127.0.0.1, 8080. And it's called Django, D-J-A-N-G-O. It's fabulous, but God help you, it's going to take a month to figure it out. Okay, so with this, we don't have anything yet, so it just says web app and it says take a picture. So what I will do here is I'll take my picture. Oh, God damn it. No, sorry. Oh, it did. I thought it was creaming at me. Anyways, there we go. So this is the cool part. So this is a web app. So what this does is when it takes the picture, is then going to show me the picture here. So imagine I'm the receptionist taking in this information. I want to see what the original looks like. I'm just printing out this JSON here just for you guys, just so you can see what's going on. And then this is simply an HTML form right here. And so first, last, date of birth, and driver's license. So what we can do is we can auto-populate this with the values that are coming in. So as you can see, first name Angela, last name Gabriella, date of birth, driver's license. So what I could do is I can simply just come down here, since this is an HTML form, and I could simply say Jones and modify it and then hit submit. So imagine, again, you have the driver's license, you're pulling out all of this information. The secretary can simply verify very specific things, modify what needs to be modified, and then hit submit instead of actually having to type all this stuff out. So this is kind of like where we're getting to with this type of thing. Again, if we take a look at this guy.
So, like those like names, like pointing out, say like Angelina from a specific, there's like no coordinates available for that, to where you could be like.
No, so if you want, as I say, if you want to make things more complicated, what you could do is you could say like, where is the last name? You could do a detection for last name.
But it would be like two queries to do both the coordinates and the name. So
Yeah.
I was wondering if you were like to hover over the HTML form and it showed you on the picture like where they pulled that information from.
You could, but
like,
it would have to be
they took the
multiple.
state name rather than the actual name.
Yeah, so that's where you would do the detect. So again, if you had, you do have to remember, so this is an M2 Max. So this is a pretty decent computer and it's running at this speed. So if you were willing to spend $40,000 on an NVIDIA graphics card, you could process this a lot quicker and then that would give you, but yeah, each one of those would be like detect first name, detect last name, detect date of birth, and then you could draw boxes around that. So you probably would do that for testing purposes and would not do that most likely in the production environment. So I can do this, picture, Smith here. There we go. So it shows his picture, John sample 01/1967, and that actually came out properly. So I could just hit submit and away we go. So that's basically what we're going to be doing with this particular lab. If we take a look at...
So you could not tell this prompt to say, give me the first name and its coordinates.
No. So detect. So how MoonDream does it is there are different functions. So query is a function and detect is a function. So yeah.
Does it create images based on the text prompt?
What's that?
Does it create images based on the text prompt?
No. So MoonDream doesn't create images. It just sees images. Yeah.
Is it possible to put like image, like let's say the photo of Golden Gate Bridge, which is it possible to ask where this place, like geographical coordinates or whatever?
Oh Lordy, I hate being a teacher sometimes. I don't. That sounds like a great question. I don't. These models aren't that big. These models are only about a 2 billion parameter model. So again, you can like something like a Golden Gate Bridge. It might know simply because that's something well known. I'm not sure. Again, I wouldn't use this model for that, basically. Yeah.
But you could also look at like geographic anomalies and tell it those. You wouldn't necessarily have to have training images on it. You could just detect anomalies within the photo. You could be like build a structure, change of color, change of texture, and And it knows where those are.
I'm not sure MoonDream knows where those are.
I mean, anything that has, it could infer a change of texture in the image no matter what. Just any box, any change of scale, that would be a...
But it might not be classified as a particular geographic object in its training set.
Yeah, because that's like if you're talking about the Golden Gate Bridge, so if you're using like Google's model or OpenAI's model, they've trained their model on like 10,000 images of the Golden Gate Bridge, and so it knows the coordinates, it knows it knows all that kind of stuff. What I'm saying is I don't think MoonDream is nearly big enough to know that to know that information. Again,
I mean,
play.
Try it, just download it and
Yeah.
query against it. Well,
Yeah.
what is this or where is this? And,
Yeah.
You know.
Yeah, you can see where it is. I would not use MoonDream for that type of thing though.
Yeah.
Just personally. Okay, so let's take a look at this code then. So this is where it gets a little bit more complicated. Again, if you don't understand all of this, one of the things I tell new people to these classes is learn two things. Like everybody tries to learn everything, just learn two things. If you learn two things every single class in a year, you'll know a lot. So just don't worry if you can't follow everything that I'm about to show you. So this is the Bottle Web App framework up here. We need to import run. That actually runs a framework, what's called route, post, request, and static file. So this is going to be one of the important things for anybody who knows web app frameworks. So you're not really supposed to be delivering those image files directly from the computer itself. That's kind of a security thing you're not supposed to do. But anyways, with the static file function, you're able to do that. So if you come down here, you'll notice I have this little function down here. So at route, we have file name path. Oh, stop doing that kind of thing. And then we have define serve static, the file name, and return static file name root. So basically what this is doing right now is it's actually taking that image file and it's delivering it to your web browser. If you do not have this little function in here, basically you're just going to get a square box with an X in the middle and it's not going to show you the image. So if you get a square box with an X in the middle, it's because your static file isn't working properly. Now if we go up here, we take a look at this. And so basically this is the home page. Whenever you see like route at index and define index, it's going to be your home page. Trigger equals request.query get take picture. If trigger equals yes, we're going to take a picture. So this is where initially you just saw a web app and you saw take a picture. There wasn't actually a picture there. So that's what's showing there. And that is on the else. So this is what's showing. So if I don't click take a picture, it's not going to take a picture. If I click take a picture, it's going to take the picture. So if I take the picture, it's going to go to camera. It's going to take the picture from the camera, same type of function that we had before. Then we're going to come down here, response equals AI image. So we're going to send the image to the AI. Same thing that we had before, return, first name, last name, date of birth, driver's license. And then we're going to print the response out on our screen just so we see it. We're going to load it as a JSON value. And then basically down here, this is where we create our little HTML page. So here is where we're going to put the image. So that image file that we created is going to go here. Then we're going to print out the response. So this is going to be that JSON response. And then down here, basically, these are the HTML input boxes. And value is basically just the default value. So anything you put in for value will be the default value within that box. And so we're simply going to be putting in first name, last name, date of birth, and driver's license into those boxes. Then we're simply returning the page. So the entire page is going to get returned to the web browser. And that's basically how the script works. So essentially all we're doing here is what we did before, only we're taking the JSON values and we're using those as the default values within the HTML forms. What's that?
Looks fun.
Yeah. So, yeah, there we go. Okay, any questions on that? It's warm in here. Okay, so then we get to go to the next thing. The next lab on my page 17, I guess your page 18, is the Find Web App. So this is where we are actually going to be creating little bounding boxes. So web bounding box. And this is too, like where we start talking about programming languages for like new people. I always get this from new people. They say, Eli, what language do I need to learn? And it's like, well, you need to learn Python or Node, and you need to learn CSS, and you need to know HTML, and you really need to know SQL, plus you should probably know Linux, right? All of these things kind of build together. So what I showed you before, right? So we have Python connecting to MoonDream, right? Then we're using OpenCV. And then from there, we're using HTML to bring in information. And so now what we're going to be doing is we're going to be creating bounding boxes using CSS. It's called cascading style sheets. This is how you can make pictures look fancy on the web. So what I can do here is, oh, I don't have Lewis. Oh, Lewis, where are you, Lewis, when I need you? Do I not have Lewis? Sorry. Anyways, I don't have Lewis. Okay, so what we can do here is I can say find, here we go, water bottle. Okay, let's see, okay, enter. There we go. So what this is doing here is, God bless CSS. You do not know pain until you've dealt with CSS. Okay, so we have the image. So what we're doing is we're putting the image within what's called a div box. Then, for each value that comes back for a water bottle, we're basically using those to create other div boxes around the items that it sees. Right, so these are the X minimums, Y minimums. These are the coordinates here, and we're basically using this with CSS to create this bounding box. So if I can say find hands, it now does that. If I do thumbs up, let's see here. Oh, no, it's not gonna. I meant to. Huh. Well, that's wrong. Let's see here. Thumbs up. So there we go. How about I do it that way? Huh. Yeah, that's weird. Okay. Anyways, so basically what I was trying to do is just trying to find the particular thing. That bugs me.
Maybe it doesn't know what might be like a gesture, it just doesn't know, like it's being
It knows. It knows. It knows this. I don't know if it knows the Golden Gate Bridge, but it knows thumbs up. There we go. All right, let's try this then.
It knows well-known images of the Golden Gate Bridge. It doesn't know random drawings of the Golden Gate Bridge.
Yeah. There we go. See, thumbs up, thumbs down.
Maybe it didn't know what was up.
Yeah, it didn't know what was up. There you go. Anyways, so this is the big thing. And that's one of the things, too, is as we're looking at this, one of the important things with bounding boxes is this starts to show us where our failures are in the system and whether they're acceptable failures. Right? Sometimes failures are acceptable. It doesn't really matter. You're like, that's wrong, but who cares? Other times the failures actually do matter. And so the nice part about the bounding box is you can start to see where the failures are. Like you might be getting failures like with lighting. Let's say you have this camera that's auto-detecting things and the lighting is really wonky. Maybe if somebody is here, it's not detecting, and they're here, they are detecting. And so by giving this bounding box, it's giving you a better idea of what the hell this thing is actually seeing. Oh God help us. Let's look at this code. Okay, let's go again. 17, I guess that's 18 for you folks. We can all just pretend we actually know what we're talking about here. Okay, so bounding box.
You should have put Taco Cat inside the tacos and other fast food.
What's that?
Put a Taco Cat inside the fast food stuff. Just hide a cat in the taco outfit.
Oh, yeah, there you go. I could do that. Okay, so here's all the functions and modules that we had before. Basically the same type of stuff. We have the static function down here, so we can deliver the static image. Then we come down here to index. Query equals request.forms, so from find. So basically this here is where we have that little text box, and the name of that text box is going to be find. So query equals get the value coming in from there. Again, taco, thumbs up, thumbs down, Golden Gate Bridge, whatever else, and we're simply going to hit submit. Then we're going to come down here. So if query does not equal none, so none is a value within Python, basically means nothing. So if there is something there, fire all of this off, else just simply put the form there. So we're going to go to the camera, as we're going to do before. Then here we're going to get coordinates. So coordinates equals AI image query. All right, so we're going to go to AI, and basically, Lordy. Okay. Oh, that's where I screwed up. Okay, so here's a query. So anyways, saying happy birthday in the middle of my class. What's going on here? It's okay, AI. So here we're going to be sending this to detect. So before we were sending this to query, now we're going to be sending this to detect. So we're doing query detect. So basically look for faces, look for thumbs up, whatever. It's going to go to the detect function. The response is going to come back as the objects that are found. The X minimum, X maximum, Y minimum, Y maximum. Basically, that is going to come back here, and this is going to be our coordinates. Then what we're going to do is for the picture itself, this is where we're going to have the gallery function. We're going to send the coordinates, and we're going to send the image. So this is where we come here. So picture equals, so this is going to be the picture initially. So we're going to say position equals relative. For the style, display is inline box, border 2 pixels, solid black. So that was the border that went around the entire picture. Height is going to be 200 pixels. Width is going to be auto. The image style, height is going to be 100% of what's here. Width is going to be auto. SRC, so the image value is going to be the image name. Then we're going to come down here, and this is going to create the bounding boxes for us. So basically, when we get the numbers back for X min and Y min and all of that, it's going to be in decimal point, so 0.49. So to turn decimal point into percentage, you multiply it by 100, right? So X equals image, X min times 100. Width equals X max minus X min times 100. So you're going to subtract those and then get 100, and that's going to give you the width. So it's basically, this is where it starts, and here's the width, and that's how you get the CSS for the horizontal line. Y image, Y min times 100, so that's going to give you the percentage down, and then height is going to be Y max minus Y min times 100, and that's going to give you the height. So it's going to give you where the point starts from the left and how big it is, and then where it comes from the top and how tall it is. We're basically going to come down here, and so this is going to be for each image in coordinates, right? So we get a number of coordinates back, and so for each of them, we're going to be creating these boxes. And so basically, this is where we create those little green boxes. So position is absolute, border 2 pixels, solid lime. So this is where we get the lime green. Box sizing, border box, left equals X. So from the left will be X, from the top will be Y, width will be width, percentage, height will be height, percentage, and we close the div. And so basically we're building those little bounding boxes up inside the image and then delivering all of this back to the web page. And then we're going to show the picture, we're going to show the form, we're going to show the coordinates, and we're going to send that to the page that we were looking at. You probably don't understand, but that's also probably okay. Do you vaguely get what's going on there?
Yes, absolutely.
Yeah, absolutely. You're so confident. I like that confidence. I don't believe it, but I like the confidence.
I mean, could I replicate that? I understand it.
What's that?
Like true AI, always be confident.
Yeah, always be confident, yeah. Basically, this is where, again, this is where programming gets difficult, is you're doing things in a way the human brain doesn't really do things. So it's like, like for image in coordinates. So you think, right, okay, I'm just gonna make these boxes. So with this, we're doing those boxes, but we're kind of doing this in this for loop. And then you're putting all of those on top of each other and submitting it back. I don't know. Anyways, but this is what you're going to be doing with the CSS. The big thing to understand with the CSS is, again, multiplying this stuff by 100 to get that percentage value. And then down here, so when you're dealing with CSS, you can either put this in as pixels or percent. So just make sure you put this in as percent and not pixels, because if you do it pixels, it's going to be all kinds of wonky places. Okay. Good enough? Good enough. Oh, anybody need a potty break? We got a little bit more to go. No, everybody doing good. Everybody's saying they're doing good. Okay, so we're going to do we got 2 more labs, and then we are done. So the next lab is going to be the Find Things gallery. So this should be on page 21 for you. Again, this is going to be playing around with bounding boxes again. Lab, bottle, bounding box. So basically what we have going on here is we have this folder, and I have a whole bunch of images in it, right? And all these images are different food images here. So I want to go through and basically see which images have the thing that I'm looking for. Oops. So if I run this is where I showed you before. Cancel. So I can say, let's say, soda. It'll take a second. And that's the other thing to be thinking about with when you're processing AI, like how you're going to do this. Do you want to do this a batch on the back end where you just trigger it and then go off and have a cup of coffee and come back with a response? Do you want it to be this in like real time? This does take a second.
Can you see that it's working?
Yeah. As long as you see the little bar going across the top, that's why I've got that there. So anyways, so we got the same thing like we had before, only have multiple images. So we have a black div around each image, and then we have a green bounding box around Coke, around Del Taco. Didn't detect those. Did detect that.
And milkshake.
Oh, we got Del Taco here now.
It's surprisingly clever.
Oh, that is a milk. Oh, you're good. I would have missed that. So yes, they didn't detect the milkshakes. They did detect the sodas. Again, all this code is relatively simple too. Basically what we're going to be doing up here is this. We use the OS module. So the OS module allows us to interact with the underlying operating system. And all we're going to be doing here is we are going to be grabbing basically all of the files from the particular folder and adding them to a list. So basically it just creates a list of all those files so that we can run through all of those different files. Basically down here, again, we have the find like we had before. So as long as query doesn't equal none, what we're going to do is image equals OS path join. So what this is going to do here is it's going to take the pick folder, so then the folder's name is pick. It's going to take the picture name. It's going to join those two together so that they look proper for the operating system. So you can do, let's say, image, pick / whatever the image name is here. You use the join in Python so that it's operating system independent. So, right, Linux uses // Windows uses \\. So if you hard code the /n, then it won't work on the other operating system. Whereas if you put join, it will just automatically figure out what / you're supposed to use. So that's why we use that here. Basically, all it's going to do is it's going to go through, it's going to get the coordinates like we did before. Then it's simply going to say picture equals gallery coordinates for X in files. So basically for each file that it's going to go through, it's going to process that, and then we're going to build the gallery. So we're going to go through. This is going to be for one image. So for gallery, it's going to get the picture. It's going to put a black box around it. It's going to get the coordinates for every item, object found in that image. It's going to put a boundary box around it, and it's going to return that. It is then going to add that to the gallery. So the gallery starts at nothing, then we add one image with bounding boxes. Then we add another image with bounding boxes, and that's what's going to give us the big old gallery. And then we're going to return everything, and we're going to turn it as the page. Does that kind of make sense? Anyway. So basically the idea like with this kind of thing is that you're going through and you're trying to process each individual thing and then you're building up as you go. The final thing is a little bit more interesting of a lab. It's a security lab. Ooh, it is warm. I do not want to wear a freaking sweatshirt in this warm. I need some AC in here. Okay, so basically what this is going to be doing is for the security lab, so 23, I guess 24 for you guys, is the idea, again, imagine like an IoT security system and you want to trigger based off of what it sees. So with this,
Like a doorbell.
Sort of.
So it recognizes a human and then sends you a message.
Where is my lab? What's it called? Lab security. Where is my lab security? Okay. So basically what's going to happen here is if there is a person in this image in orange clothing, answer orange. Ugh. If there's a person in the image without orange, answer person. If there is no person, answer empty. So again, one of the things I find interesting about this IoT stuff is, again, back in the day, I started off in the military, I got my criminal justice degree, dealt with security and all that kind of thing. And one of the very interesting things with security in the real world is how you build up an environment that kind of convinces people not to be there, right? People think about security and they think about body armor and guns and big beefy people that are gonna beat the crap out of you. What's amazing is they've done studies. So if you have a house, like even in a bad part of town, and you create a little garden bed. So you just put a flower bed that goes around the perimeter of your house, that will keep most people off of your lawn. Like there's this weird thing, like if you have no garden bed and you just have a lawn, people will be napping in the middle of your lawn, the dogs will be pooping on it, the whole 9 yards. So everybody thinks about security, and they think about putting these big ass fences and cameras and all that kind of stuff. What they found statistically is you can put like a little 1 foot hedgerow around your property, and that will keep most people off of the lawn because it's just like one of these psychological things. It's like, oh, I don't feel comfortable going onto that lawn. So that's one of the things like I think about with this. And so what this is doing is imagine orange is my uniform. So imagine I have a company, everybody is supposed to wear a color, blue, orange, green, whatever else. So when it sees somebody in that color, it'll think it's okay. We can turn on a light, we can play nice music, whatever else, right? If we see somebody that doesn't have orange on, we turn on the sprinkler system. Right? We don't have to beat the hell out of anybody. We can just turn on the sprinkler system. Or you can put on Frank Sinatra. So like 7-Elevens not that long ago realized that if they turned on Frank Sinatra outside of their premises, it got rid of all the homeless people. Because there's only so much Frank Sinatra people can do. Like, it's real. Like, this is actually a true thing. So anyways, basically what's going to happen is if there is a person here, it's going to play an alert. If there's a person in orange, it's going to say, welcome. And if there's nobody here, it's going to say, play crickets. Anyways, it's not a good cricket, but it's what OpenCV gave me. So, okay, let me run. All right, so let me do this. So that's crickets. Come on. Come on. Oh, maybe it is. I see my desk doing this.
It just takes a while.
Killing me here. All my live demos are weird. It's not the code, though. It's MoonDream.
Didn't pray to the demo god.
Yeah, I should've. Yeah, no, I should be seeing me.
Does it need more of your body, maybe? No? Like, is a person a full body?
Let's do the orange hoodie.
No, I just tested it earlier and it was hit on.
Try making just the hoodie with no body.
Yeah, hold on one sec. Oh, where am I? Oh, yeah, stop that. Yeah, okay, there you go. All right. Ugh, put on a sweatshirt. Yeah, I guess the live demo gods got tired of me and they went home. Your classes are too long. Oh, whoops.
That worked.
Welcome, I'm glad you're here.
Thank you.
Welcome, I'm glad you're here.
Okay, come on now. Oh, there we go. There we go. Yeah. That's what I like out of my live demos. Son of a bitch. Am I not a real person anymore to you, computer? Yeah, it's not intelligent. That's weird. I don't know. Here, I'll detect you guys. Come on, MoonDream, you're killing me.
No, we're not person by.
Anyways, I swear this was working. Am I real? Is this the real life?
Welcome, I'm glad you're here.
What the? Yeah. Yeah.
What does that alert sound say?
God damn it.
It recognizes the orange, it just doesn't recognize person.
Yeah, I don't understand why.
Maybe the like color, since you're basing it off of colors, there's
Maybe color is more specific than person.
No, I tested this at home. It was working fine yesterday. I'm not I'm not sure.
maybe because of the different background.
I got it working.
But okay, you got orange on. Okay, flip it over to me.
Actually get into.
Welcome, I'm glad you're here.
I don't know what port it opened on, but I mean, you're happy to, more than welcome to plug into HDMI.
Welcome, I'm
I don't
glad
know.
you're here.
Well, no. Okay, so no. Is it? Well, so no. It should be firing off of me now. Am I not real? Here, let's find. Oh, you stand there.
Empty.
Huh. Yeah, I don't know.
Lower the timeout between taking pictures.
What if you increase the sleep?
Yeah, maybe your sleep's too low.
Maybe.
I don't know, light.
Well, no, because the captured image. See, I mean, that's the image it's processing off of.
Alert, alert.
Oh, there we go.
Alert, alert.
All right. So that's what it's supposed to be. Alert, alert. I don't know what the hell it's doing, honestly.
Orange is what it was doing.
Let's see here. All right, so there's that. Now let's be all fashionable.
Welcome, I'm glad you're here.
There we go. It works. Yay, we're done. I'm going to kill it right now. We're going to take that as a success. All right, yeah. And again, that's why with all of this stuff, you test. So basically all we're doing here is we're taking the image like we did before. We're sending it up there. Again, with this whole time for making sure the image looks how it's supposed to. That's where you can go here and take a look at the captured image and just verify what it's actually seeing to understand why it's trying to fail out. And then basically all we have down here is, again, if there's a person in this image in orange clothing, answer orange so that we can trigger based off of that. If there's just a person, answer person. If there's no person, answer empty. And this, again, this is where we get back to that whole disaster of prompt engineering. Is honestly, if I word this, whatever the hell better is, if I word this differently, I might actually be able to get it to respond better to me. And that's where you just have to sit here and play a whole bunch to see what's going on. Again, when you're playing around with this type of thing, like I noticed at home when I was doing this, I have weird little stuffed animals and things on my bookshelves behind me, just weird stuff I've picked up over the years. And so sometimes it'll see those as faces or things. It'll see reflections. So like I was doing this thing where I was hiding over here, but then there was a reflection of me in a glass surface, and so it triggered. And so again, that's the other thing where you have to actually play around with this stuff to see how it's really working. So yeah, so that is the class for tonight. Is there any question on that? Yep.
So, I mean, in my own work, I work with a very specific body of images, X-ray images. The goal is to find certain anatomical features.
Yep.
I'm assuming that MoonDream is not the tool for that.
No,
right?
no.
You cannot train MoonDream on a specific body of, like you would use some other AI tool to train up a detector for a specific body of images.
Yes, so that's where, so you might use something like OpenCV, like depending on how similar the images are, like tumors can be really weird. But if they're relatively similar, what you can do is with OpenCV, basically that framework where we're taking the image, there's a whole bunch more to that. One of the components is you can actually train it. So you could take 500 images of a specific type of tumor, and then you go through a whole bunch of processing, and then it would then be able to go through, and it can actually give you XY coordinates too. So it could scan and say, okay, here's a tumor, here's a tumor, here's a tumor. But yeah. So you would use something else for that, yeah.
Would it be easier to just train on non-tumor images and then just detect not standard? You could just anything non-standard as an anomaly?
You know, that's where you sit down with your GPU and figure it out. Yeah. Well, that's the thing is like with a lot of this stuff, like, can you do it? That's where. So when you do the train, so like with OpenCV, when you do the training, what you do is you give it a large number of images, but depending on, it can be anywhere from 20 to 2,000 images or even more. So you give it the image, and then you give it the location of whatever is you're looking for in the image, and then you also give it a massive set of not tumor images. So you have 2,000 tumor images and like 10,000 not tumor images. And then what happens is when you're training it through this neural network, is it's going through and it's actually training itself. So it says, okay, I think that there is a tumor at this location. Does this image even have a tumor in it? If not, oops, I'm wrong, readjust some stuff. Okay, there is a tumor here, but it's in a different location. Again, readjust some other stuff. And so it keeps going through and processing. So yeah, that's what a lot of this stuff is, figuring out how to design your systems, yeah.
So how does this OpenCV and this
MoonDream, yep.
Already forgot.
MoonDream.
MoonDream.
Yep.
How do these compare with YOLO?
YOLO. So basically, YOLO is a different model. So a lot of times you use YOLO with OpenCV. So we'll probably have a class on that in the future. So with OpenCV, like with video, every time it takes a frame, you can run it against like one of these image processing things, and one of those is YOLO. And so YOLO is a detection tool. I was just looking at it. YOLO, I think it's 8. It's something like hundreds of different types of objects, but it is hundreds of different types of objects. And so it'll show you cat, it'll show you dog, again, whatever it was trained on. It can very quickly show you those particular things, but it's not as flexible as this. You can't put this into YOLO.
Yeah, that's different.
Yeah.
It has LLM also combined.
Well, yes. Well, YOLO, yeah, again, YOLO is it's an image model. So like with YOLO, what you could do is you could say, basically, is there a person in this image? And then you could say, within that bounding box, is there that particular orange? So again, you can work yourself to this point, but it would be a different process to kind of get there. Yeah.
But it's a better detection model?
It's faster, hell of a lot faster. Yeah, like when you use OpenCV, so if I do like facial recognition, like so you can run it straight for the video feed, and it'll be going at like 30 frames per second following along, whereas this will go at like, I don't know, a third of a frame per second basically. Yeah, or a frame every 3 seconds really.
Why is there like such a speed difference?
Because basically it's what it's designed to do. Like with, if you're using, like with OpenCV, generally when you use OpenCV, you're only looking for one trained object, so it's only faces. So it only has one, basically, fingerprint or whatever to look at, so it's a lot quicker. Whereas this, I mean, you can basically ask this whatever the hell you want, and it will try to give you a response. Yeah.
I think this one is, the best use case for this is like detecting the driver license or something, receipt or something. Simple extraction.
Or if you have like a motion sensor, they'll only trigger the script when someone's actually in front of the camera.
Yeah. So yeah, so this could be, it could be that, it could be, again, if you're saving a lot of images, let's say you're coming in from a security camera, let's say you have 100 security cameras, all that's getting dumped into one location. The other thing too is, again, just think about like architecture and resource consumption. I mean, like it's funny to laugh at spending $40,000 on a GPU. To me, that's a little bit of money. But again, to some companies, $40,000 on a GPU, they might be like, give me 5. And so again, if you were running this on an actual, like one of those H100s, you know, this thing would run a hell of a lot faster too. So yeah.
Seems like for security, security systems, it's pretty powerful.
Yeah.
Like, or just like scanning through stuff. I can't imagine what the government's doing with this now, like scanning through anything they have.
Yeah.
Data mining, I guess.
Well, the other thing too, what's interesting with this, and again, you talk about that thing with architecture. So our next class is going to be using Raspberry Pis at the edge. So again, one of the things to be thinking about with like network architecture is, what does your network look like? Like when I'm talking about this, when we talk about IPv4 versus IPv6, think about things like SMS. So one of the things I'm going to show you guys, hopefully, as long as it works properly, is I have this really cool card from this company called Blues. And so basically, this is an LTE card you can plug onto something like a Raspberry Pi, and it allows your Raspberry Pi to both send and receive JSON data, basically just with an LTE connection. So you pay $50 for this thing, you get 500 megs of data over a decade. And you're only sending JSON, you're not sending full images or anything like that, so JSON 500 megs is actually a lot. So what's cool is you start really thinking about this, because you can send data both ways. So imagine if you had security cameras over a massive facility. Let's say you had a military facility, and you don't necessarily want Wi-Fi and all that crap because you can have problems. So imagine you had all of these cameras throughout this facility, and somebody broke into the PX. And you're like, I know somebody in an orange jumpsuit just broke into the PX. So I could send out a notification to all of my cameras to say, look for somebody in an orange jumpsuit and tell me if you see them. And basically, as somebody runs by, it doesn't need to send me the entire image. It can just simply say, I see somebody in an orange jumpsuit, and I can send the MPs just to that particular location. And that's, again, that's one of the things to be thinking about when we start talking about artificial intelligence, is like, how do we build systems for 2025? Like, one of my frustrations, having done technology for so long, is it's amazing. We use computers basically the same way we did back in 2000. Again, we're using keyboards, we're using mouse. Now we have touch screen. Like, our new thing is touch screen, and that's about it. And so one of the things to be thinking about is, how can we fundamentally shift how we're designing these systems in ways that couldn't be done before? Something to think about there. And so that's where, like, again, like things like this is just thinking like how you can design that kind of stuff. Do you need a 4K image to come back to your security operations center, or do you just need to be flagged when something happens? That type of deal. Yeah. Am I the only one that feels very hot in here tonight?
No.
No. I'm like, ugh.
You just need to get out.
Yeah. Okay, so that is the seminar for tonight. Whoever wants to stay, you can keep staying for a while if you want to. But if you want to stay and you want to play with things, I will help you be able to write some code or try to figure out what problems you're having. If you don't want to stick around, you don't have to stick around. That's basically the seminar.
Just because I'm new to this and kind of crashed it, like,
Yeah.
Do we pay for these, or like how would? Yeah, I know I just like walked through the door. It's like, yo, there's a thing in Durham, and so I came.
So basically, if you go to silicondojo.com and you click on this nice little link that says donor box, this is here. So basically the idea is this is crowdfunded, so my viewers and a lot of other people throw money into the pot to try to make this happen.
Awesome.
So, yep.
Will do.
Yeah, cool.
Yeah, I mean, thank you very much for being, for letting me crash this.
No, yeah, anytime.
Thanks.
Yeah.
This is great. What is this function routing with AI? What kind of use case this is about?
Oh, that was from like one of the other ones. So, shift gears. So we did a class like using REST APIs. And so with REST APIs, you can pull information in. So you can pull in like weather, you can pull in jokes, you can pull in AI things. And so with the function routing, what it is you can create a file that just has your functions. So this is the function for weather, this is the function for time, this is the function for saying hello, goodbye, whatever else. And so basically what happens with that particular script is I can say, hey computer, do I need an umbrella today? And what it'll do is it'll go through, it will find what function needs to fire, so basically the weather function. It will fire off the weather function, bring in the weather report. It will then look at that weather report and say, okay, does he need an umbrella for this type of weather? And then give you a response. So that's basically what the function is. It allows you to very organic, like people to be able to organically talk to the system. Like so with so much of programming before, you had to hard code things. So hello equals hello, goodbye equals goodbye. So with that system, I can say hola, and it will say hello back to me. I can say bonjour. I don't have to code it. It knows that bonjour and hola and guten tag are all hello, and it will simply trigger that hello function. Yeah.
It's like an agent framework.
It's not agent. Oh, we get into that. No, it's not agents. It's not agents is a whole different thing.
MCPs.
What's that?
MCPs.
No, so MCP. So when we start talking about, so this is just function calling. So when we get to agents and we get to MCPs, agents are about your AI is doing something for you. So if I tell my AI I need a haircut, and I have in my system what barber I like, and I also tell it I want to get my haircuts in the afternoon, basically like what an agent system would be able to do is it would be able to look at like the RSS feed or the calendar for my barber. It would see whenever there is an open afternoon slot, and then it would actually be able to then grab that slot for me and auto schedule. And so when we talk about agents, we actually talk about the AI system is taking an action for us. It is ordering an Uber for us. It is scheduling a barber appointment for us. That's what an agent would do.
So the reason I'm asking you is, what if I replace this function with an action, like my book output?
Yeah, you could do that in there. But then that would be an agent. Then you build on that. Yeah.
So I can replace these functions with actual action APIs.
Yeah, as long as you know what you're doing. Yep. It's like, can you? Yes. I mean, well, somebody can. Whether you can, I'm not sure.
You gave the whole script here. Let's remove it.
Yeah, that's not. Yep. Oh, somebody say, yep.
Oh, do you want these back?
You can take the paper. Don't take the binder.
When you start the MoonDream station, it asks about the token, Hugging Face token.